Thank you, Bree. My presentation today is an introduction to nature-based solutions. Let's start with the definition. Nature-based solutions help manage, protect, and restore natural ecosystems. This could be a wetland, a forest, a mangrove, anything really. Nature-based solutions help address problems like climate change, biodiversity loss, water security, food production, disaster risk, and human well-being. Some examples might give us a better sense of the three nature-based solution categories and what they mean. Parks and protected areas are a great example of protecting ecosystems. This category of nature-based solutions is based on the idea that left alone, nature will flourish. Other initiatives like improved forest management, prescribed fires, forest thinning, these sort of interventions could reduce fire severity and keep precious carbon from entering the atmosphere. These are all great examples of managing ecosystems. Like parks and protected areas, these initiatives are also considered nature-based solutions. Lastly, let's consider restoration. What is it? It could be something as simple as reintroducing water to a degraded and dried peatland ecosystem. Now that we've understood the broad categories of nature-based solutions, it's important to put things in perspective for the Northwest Territories. Where exactly is the carbon that we care about? Three numbers matter. First, the NWT has a net zero commitment. We want to reduce greenhouse gas emissions from fossil fuels by about 1 million tons. The second number is 356 million tons of carbon dioxide equivalent greenhouse gases. Recognizing 2023 was an unprecedented year for wildfires, the Northwest Territories emitted nearly 2 times the emissions from its last major fire year in 2014. And finally, 24 billion tons of carbon. That is carbon estimated in NWT soil, carbon that is below ground and vulnerable to peatland degradation and permafrost thaw. Now, these are huge numbers, and they highlight why natural ecosystems deserve our attention. What could a hypothetical nature-based solution look like? Consider this carbon density map of the Wood Buffalo National Park that Chelsea also referred to yesterday. Generally, Canada's parks act as carbon sinks, which means they absorb more carbon than they release into the atmosphere. The Wood Buffalo National Park is an exception to the rule. In the period between 1990 and 2019, the park has emitted an average 2 million tons of greenhouse gases per year. The park is a source of greenhouse gas emissions. Knowing that there are management restrictions in parks, hypothetically, an intervention across this landscape that detects wildfire at an early stage to suppress it or uses prescribed burns or forest thinning could potentially make the landscape on this map carbon neutral. If we could do this for a similarly sized and vulnerable ecosystem in the NWT, that could entirely offset NWT's carbon emissions from fossil fuels. This may sound easy, but it's not. Back to our Wood Buffalo National Park example, Parks Canada actively manages wildfires within the park, and yet it has been a source of carbon over the last 3 decades. Clearly, additional tools and resources are required to make this landscape carbon neutral. Our ideas for improved forest management cannot start and end with the Wood Buffalo National Park. We have to think bigger. Historically, Canada's parks and protected areas have been a carbon sink. In recent decades, the situation has changed. Even though the boreal forest has a fire-driven ecology, more intense wildfires and insect outbreaks have turned this carbon sink into a source of carbon. The black horizontal line on this graph signifies net zero emissions. The fluctuating blue line traces greenhouse gas emissions for parks across Canada. You can see on the slide that the blue line has remained above zero since 2002, highlighting only net positive emissions since. Beyond forests, the carbon stored in soil is also under threat. Globally, permafrost soils store roughly 1,500 gigatons of carbon. That's about 40% of all soil carbon stocks. That's also nearly 3 times the carbon stored in above ground vegetation and 2 times the carbon currently in Earth's atmosphere. The image on the slide shows carbon across 3 different permafrost soils, up to a depth of 3 meters below ground. The black horizontal line running across the 3 charts showcases the typical depth of the active layer of soil that thaws and freezes. Everything below the black line is permafrost. In each case, whether it's ice-rich or soil-rich permafrost, we can clearly see that a majority of the carbon is stored in permafrost and not in the active layer of the soil. This highlights why thawing permafrost and the anticipated emissions from that thawing are such a significant threat to our planet. This is a map of the NWT showcasing that the majority of its land mass is underlain by permafrost. The darker shades of blue reflect more continuous areas of permafrost compared to the lighter ones. With much of the NWT's carbon locked in permafrost, protecting this resource is vital to mitigating climate change. A key question to ask is this: is there a nature-based solution that could help protect this permafrost from thawing? This is where the idea of the Pleistocene Park comes in, an idea inspired by the Pleistocene era, when large herbivores like mammoths roamed the Arctic, compressing the snow on the ground. In today's world, a large number of bison and caribou could potentially help achieve the same goal. They could compact the snow as they move across the land. Ideally, this would reduce the insulation on the ground and cool soil temperature. So what exactly is the Pleistocene Park? In 1988, a Russian scientist, Sergei Zimov, introduced a dozen Yakutian horses to protected land in northern Siberia. The picture on this slide is of those horses from Pleistocene Park. Over time, Zimov introduced 150 additional animals. The animals were allowed to roam and naturally interact with the snow and vegetation. In the graph on the right, the red line traces soil temperatures from the park at a 90 centimeter depth, and the blue dotted line represents soil temperatures at the same depth outside the park. One can clearly see that cooler soil temperatures were recorded inside the park. This experiment demonstrates a potential nature-based solution to protect permafrost. To put it simply, less insulation above ground means lower soil temperatures. The important thing to remember is that compacted snow leads to lower soil temperatures and heightened protection for permafrost. So what does the Pleistocene Park idea look like in practice outside Siberia? Observations from the Holmen Island in Sweden show that 15 reindeers per square meter can reduce snow depth by 17%. Professor Christian Beer teaches soil processes at the University of Hamburg. He uses environmental modeling and sensitivity analysis to show that even a 17% reduction in snow depth can reduce permafrost temperatures by roughly 0.5 Celsius. To learn more about Pleistocene Park, you can also visit pleistocenepark.org and some additional links to an article and a documentary on YouTube. Feel free to take a picture of this slide with your phone if you're interested in reading or watching more about the Pleistocene Park later. In conclusion, I want to leave you with the 3 broad categories of nature-based solutions. Let's use our time at this workshop to explore opportunities to protect, manage, and restore our natural ecosystems. And let's not forget, there are many different ways to do this. Thank you for listening. Please feel free to reach out if you have